Hey, everybody. My name is Anna. I'm the host of a podcast called Zero Knowledge. I'm also the co-founder of a company called ZK Validator and the co-creator of an educational portal called ZK Hack. And we just did a hackathon that ended yesterday. So my voice is actually, I'm just realizing as I speak to the mic, suffering a little bit. So I'm here with 4 guests from 4 different projects. I know 3 of you just did lightning talks, but I think it would be worth it to do a quick intro to each of you and your project. Why don't we start with you, Rami?
Hi, my name is Rami. I'm an engineer at RISC 0. I've recently been working on Zeth.
I'm Rushi. You saw my super lightning talk. I'm from Movement Labs, bringing the MoveVM to the Modular stack.
Dino, co-founder of Fluent, and we are building the ZK WASM execution layer for Ethereum.
I'm Kautuk. I'm the founder of Stackr Labs, and we are building micro rollups to scale Web 2 and Web 3 applications.
And yeah, so I mean, I think starting out, one of the questions that I have definitely is about like EVM, and like here we're talking primarily about VMs, and I know I just saw your lightning talk where there's a transpiling to EVM, but why didn't you decide to just build the EVMs like a lot of these other teams are doing? Like what drove you not to do that?
The EVM is broken. Every year there's $4 billion lost to smart contract hacks. If you have asked any Solidity developer, hey, do you like coding Solidity? 99% of the chance, unless they're clinically insane or worked at consensus, something like that, the answer is no, right? Security is at the forefront of our thought process. And every year there's so many hacks. You go on Twitter, you'll see like, oh, it's a $40 million hack, oh, it's a $60 million hack, but no one actually is like, how can we change this? And that's kind of the thesis behind like DM project. They were gonna use this new programming language to power Facebook's decentralized network in their stablecoin. Obviously, SEC struck down, but now that thought process comes back to our stack. How can we take this Facebook's billion-dollar programming language, bring it to the execution layer, and then bring it to Ethereum? So that's kind of how we looked at it.
And what about you, Dino?
So most of my background before the last 3 years where I got deep into crypto was in kind of like Web 2 developer tooling and infrastructure. And if there's one thing that's become very clear over the past, I guess this the mobile cloud boom is that, and the kind of the general microservices architecture that people use to build apps today, is that like developers want to pick the best tool for the job. And so we just at the core don't, believe in trying to make developers kind of learn all of these blockchain specific things. And we think kind of opening up to new languages is kind of the first step towards kind of unlocking like better developer experiences. And I think that there's a plenty way to go after that in terms of like abstracting things away from developers. But we just think that's like just crucially important if we want millions of devs.
I was just thinking though, like the EVM also does have a lot of tooling for these developers. In the case of Move, it's a younger language. Does it have the same kind of tooling, or does it not need the same kind of tooling?
So that's kind of why we designed the compiler, right? So like the truffles, the hard hats, that's all fully compatible with the underlying VM because the SDK itself transpiles the bytecode, right? So you get all the benefits of like EVM tooling, EVM community, you can get Curve Aave deployed seamlessly, but the underlying VM has the provers, which makes it secure, and you have parallel processing. So yeah, all the tools are there, and we're building out a lot of additional tooling as well.
Okay, and what about for ZK WASM? Do you get to make use of the WASM tooling?
Yeah, pretty much. So it's less of a less friction to get started, kind of building that type of ecosystem, just because we don't have to start from scratch. And we honestly, obviously, there are a bunch of different approaches to kind of like the alt VM solutions, and we just find WASM to be like a really excellent kind of sweet spot on that trade-off space because it does provide so much flexibility, but at the same time, there's also a lot of kind of like I'll say like brand recognition of it. It's very popular already. People know WASM, and it comes with tooling.
Does your system also have any connection to EVM?
Yes. So we do support Solidity and kind of like all EVM tooling, basically.
Kautuk, I want to ask you a question. I missed your lightning talk, so I didn't actually hear like what language or kind of toolkit would people be using with your system?
Right. Yep. So I basically talked about like building microservices for the Web3 world, And these microservices could be, like the micro rollups that we are building could be implemented in any sort of language. So the idea behind that is you build your application in, and that executes in their own runtime. So that allows you to build any sort of application in any sort of runtime. And that then there's a layer in between, which is the auditor layer, which sends it to L1. So the executor layer is completely agnostic of whatever tooling that you need to do. And it's completely like different from like the other VM sort of paradigms.
And yours, does it then kind of like, does it become a roll-up on Ethereum, or is it a roll-up for any network, any kind of base chain?
Yep. So we can decouple the settlement and the DA, and it can actually get on top of any L1. So the settlement can happen on Ethereum, while the DA comes on another the data availability layers of some sort. So yes. So technically, it can run on any chain.
Great. So I think I'm most familiar with the RISC-0 project, but why don't you weigh in here? So I know it's Rust-based. You decided not to do EVM. Why?
Well, well, because we have the prover for the RISC-V bytecode. So that was mainly it. But in the end, we also ran EVM. We emulated the EVM inside of our system. So we're kind of a jack of all trades in this sense. We can be a roll-up that is just an application that sits on Ethereum. You can also enshrine Ethereum inside of the RISC-V ZK VM.
Is that the Zeth? Is
Yeah.
that's an EVM roll-up? I know I spoke to your founders about this, but
Yes.
I forget how does it connect to RISC-V?
So we run the EVM inside of our prover. So we basically compile down the revm crate into the RISC-V bytecode, and then we run that as an executable in our ZK VM.
Okay. And what's the name of it? This is Zeth, right?
Zeth,
Yeah.
that was Zeth.
I actually was curious about when you talked about this transpiling down, if there's any kind of like loss of performance. Like this is, okay, so I'm not a developer, so I might not fully get this, but like, do you just do that once when you're like deploying the contract and then you never have to do that again? Or do you end up doing that often and it could actually like affect performance?
Yeah, so you deploy the contract once, but every time you invoke a function, let's say, like you're deploying curve. The curve deploys once, but every time a user calls a function, it just calls opcode, like mapping it.
Yeah.
It's like 146 facility opcodes, it's 54 move opcodes. So it's a one-time deployment, but the functions are called repeatedly.
But does that affect performance then? Like the
No.
fact that you're doing this kind of transpiling?
Not so far. Our TPS is like for the EVM, it's on 60K, and obviously in theory, and the move VM is 146K. So you lose like around half, I would say, but still it's like 60K theoretical, still pretty good, I would say.
Okay.
So you can either choose to write move, which we'd encourage you to. The solidity side is more to like, hey, like if you don't want to, there's also some functionality.
Okay. And actually in the RISC-0 case, is there any loss of performance in something like Zeth?
Well,
Like using EVM
yes.
in this context? Because, yeah. Oh, in this case, it's not transpiling, though. It's just full EVM. It's a fork,
It
right?
is essentially just running the EVM inside the prover.
Yeah, okay.
And that does come with a bit of an overhead, especially because we haven't really optimized that revm crate to run inside our ZK VM. And in the end, you have the overhead of emulating the EVM inside of a ZK VM instead of directly specifying a circuit or a proving system directly for the EVM bytecode. So there is a bit of an overhead, but it's not like a 10x overhead. It's more like 2x or.
The overhead would be like proving costs in this situation, right? Like
Yeah.
to run these provers. Is there any like estimates for like how like just compared to normal EVM running compared to like when you have a prover that's running the ZK EVM, how much more expensive is it? Do you know?
It is hard to get those kinds of
Yeah.
metrics because it's not apples to apples.
Yeah.
But for example, to prove an entire Ethereum block, I believe it was $20-ish. And it's more of a cost effectiveness trade-off because if you do want faster proving time, it's all fully parallelizable. You can just add in more GPUs and then you can go down from 50 minutes to 14 or even less. So.
I want to go back to Kautuk about these sort of mini roll-ups. I asked you if it had to be on Ethereum. You were like, actually, the DA can be somewhere else. But is your project sort of in the same category as like those like roll kit? Is it meant for like a developer would approach it not to build upon a roll-up, but rather to deploy their own always?
Yes, exactly. So if you really want to compare, so I think a good comparison would be Rollkit, Sovereign Labs, OP-Stack. So it's a different rollup framework. It doesn't allow you to spin like the same framework. It's a framework on its own. So yeah.
What's different about it compared to those?
Yeah. So as I mentioned, so it allows you to like it separates the execution and the verification. So you just build your application as a regular Web 2 application. So like similar to how you build like backends, you just build your application like that, and it just collects all the data. So we're building an execution pipeline which takes your logic. So you build your application and you build the state machine the application logic as a state machine on its own. So that a state machine is specific to your application. While the others give you like a VM, which is the state machine, and then you deploy that application on that VM. So instead of us, so you build your own state machine in our case.
Interesting.
Sorry, how does the verification work? Oh.
Yeah, so we have like two modes of it. So one of them is the audit process, which is simple re-execution. The other is like converting the binaries into like a WASM compile, and then from WASM to like running it inside like a ZK VM. So that's like the other mode. So you can just take the application logic, you take the state machine, we have like a fixed abstract method for it. You just need to comply with that, and then it converts the execution pipeline, converts it into like a WASM bytecode, and that runs inside a ZK VM. So yeah, we are actually trying out like different methods.
Rushi, I was wondering kind of about, because you're working with the Move language, which, and I don't know if you mentioned this, but it originally comes from the team that is now SWE, and I think Aptos. Do you have any connection to them? Or is this like you're just using you're just focused on the Move language?
Yeah, so I built the first Dex in Aptos. My
Okay.
co-founder built the first yield aggregator Aptos, and it's like August of last year. So we were two of the first builders in the space.
Okay.
And we're like, this language is cool. I want to use it. And then FTX happened. We're like, damn, that's sad. And then we're like, okay, let's just do something else.
Cool. I wanna talk about use cases for each of these systems. And I'm curious, I'm sure given that you're so deep with your system, you'll have sort of like the ideal use case, but I'm curious if any of them are the same. So I don't know, maybe we start with you. Like when and I know RISC-V is like quite general purpose, but are there any use cases that you would say like you should definitely be using your system?
Well, it depends on how you want to compose your system, I would say, because you have a lot of flexibility, whether you want to be a rollup or you want to ZKify some pre-existing system. So it's hard to say without knowing what the objective is.
Would you say maybe also here in this case, like the use case is actually like a rollup builder, kind of like it's like a type of rollup deployment that or like some, like I know you guys have also touched on the coprocessor side of things, so.
Yeah,
okay.
so if you do have one application you'd like running on an L1, you can use this coprocessor model to offload the execution to that ZK coprocessor and then have provable results returned to your blockchain. So that is also another way you could do it.
Okay. What about you? Do you have like a dream use case?
I mean, I think every infrastructure project is trying to find use cases. I think you'll get the normal answer of like DeFi, gaming, NFTs, which everyone is trying to do.
Yeah.
So I think if you want to go uniquely, I think you look at the developers, right? And I think we're focused more on security-focused developers. People who are like, I want to build security-focused apps. I want to build like on top of parallelized runtime. I think those are two main avenues, DeFi for security for obvious reasons, and then on the gaming side, or any consumer app, having high throughput is important, but I'm sure every infra builder says that.
So let me actually separate Fluent network and kind of like the general purpose smart contract environment that we're going to market with from kind of like the broader framework, which Dimitri might have talked to earlier. As we're kind of getting this smart contract environment going, we are making some optimizations for like higher throughput use cases. And mostly this is from conversations with devs over the past half year where, a lot of people who are building in like gaming, social, like consumer-y looking use cases seem to really want to use kind of like very simple Rust, TypeScript, Solidity on Ethereum. That's kind of like our initial focus. And so obviously we optimized kind of the network around that because I think the Fluent-based design will enable much more flexibility for all different types of use cases. But to go to market, we'll start off with a kind of an optimistic ZK kind of like design. So there's higher throughput there. and we'll be putting all kind of like, input data on EigenDA. So we're making some of those design decisions to, work better with things like on-chain gaming and stuff like that, and we're starting to get a lot of interest there. So I obviously it's a permissionless general purpose system, but like I am very excited. I'll put it this way: I'm very excited about those types of like net new use cases.
Any particular?
Yeah, so for us, we're going to the consumer apps like that exist today from the likes of Uber and like Microsoft's and all of those things. So our main objective is to progressively decentralize Web2 kind of applications. So I think it's interesting that Vitalik did a post like a couple of weeks ago, which was like a different type of L2s. So that is basically what we are going towards. So yeah, all those applications which the term he mentions halfway house of security, like applications which want to have some part of their stack decentralized while progressively going towards like full decentralization. So that's the kind of applications that we are targeting.
I'm going to actually ask a similar question, but switch it a little more towards like what kind of developers should be using it. So in your case, you mentioned it's like you can run any language, but are you maybe as a company kind of really targeting one group or like thinking about one particular language that some developers are using?
Yeah, so we are starting with like regular web developers, so that's why we are starting with JavaScript, because like web application is like makes up 99% of all the applications, 1% is all of the other. Don't quote me on the numbers, just like a exaggeration, but yeah, that's what we are going towards, like web developers who are using JavaScript. Then we'll eventually go to Python and then Go, Rust, and all of those things.
So JavaScript developers are going to be deploying rollups?
Yep.
Wow.
And those rollups are going to run in their browsers.
Okay. And in your case, I guess WASM, but like, what kind of developer are in that community? And maybe actually you should answer, which languages?
So obviously the goal is, we support any kind of language that compiles down to WASM, but like our initial focus, which I think is kind of your question, is around kind of Solidity, Rust, and TypeScript, which you can all kind of blend together nicely. And I think developers who want to do that on Ethereum, whether we're seeing developers who just want to, it could be very simple. It's like, I want to program in Rust on Ethereum. Just easy way to put my dApps in Rust on Ethereum. To people who are building kind of like more, some of the autonomous worlds use cases where they're like, hey, I want to put kind of like the core logic of this thing in Solidity, throw some financial mechanics in there, and then make it permissionless to anybody to like extend that game or that world in some other language. Like, these are the types of, I guess, developers that we're starting to kind of appeal to. And yeah, I mean, maybe that's a little bit of a different answer from before, hopefully.
Yeah. In your case, I guess it's Move and Solidity.
It is Solidity compatibility, but I think the bet is really on like similar to like Solana Eclipse thesis, right? You have this big L1 with naturally big funding and like a big ecosystem around it, and the thesis, okay, if Solana developers are kicking up, they're going to want to bring it to Ethereum. The same thing as us, right? Both Aptos and City raised $300+ million. The combined market cap is ridiculous. So the bet's over the next few years, if more people already move, which they are, specifically in Southeast Asia and Korea, we're going to provide a way for them to bring it to Ethereum. I actually have a question for you guys, because we're probably more in the Rust playbook, where you guys are WASM. I'm a Cosmos WASM dev, and I know the hype was in Polkadot and Cosmos back in the day. How do you guys get over like the WASM derogatory, if you will? Where it's like, WASM is dead, but in reality, WASM is just a backend. But if you're going to be marketing WASM compatibility, how do you guys like navigate that?
It's a good question. I honestly, at this point, we have focused mostly on people who are excited about WASM, and there's no shortage of them. And so as much as there could be for people who have been in the space for a long time, and yeah, maybe there's not a bad taste in their mouth, but they could have seen like, oh, well, WASM was tried here and there, and you know, why are you guys picking that? I think for every one of those, there's a greater number of people who are actually just excited about what WASM kind of offers. So, I mean, how do we, that's the best kind of answer I got right now, just kind of focusing on the people who are excited about it.
And in the case of RISC Zero?
Yeah, I definitely see hybrid approaches working quite well, because we're not really a network. You know, some pieces we actually don't target at all, like data availability or interconnectivity between things. So I definitely see developers using possibly the ZKVM in some parts and another platform or another language as a top or bottom layer for that, depending on their needs.
Also, I just thinking back, like in terms of use cases, didn't you guys also make there was like an ML use case, sort of
Yes.
this
Yep.
running machine learning, like allowing for so much computation to be happening in these other environments. Is that still a use case for you?
That still would be a use case. It is a type of computation that you can basically offload or perform privately and then provably show your results for.
Cool.
So hybrid approaches all the way.
I have a question here about onboarding new developers. So I think we've talked here a little bit about who you're trying to reach out to, but yeah, how do you get them to use your system? And actually, I don't know, are any of you, like, is your project at the point where you're like actually actively trying to get them to use it, or is it still in development? So maybe say first, yeah, the status of the project and then what you're doing.
Yeah, so we are actually like releasing a developer preview about next month. And for adoption, I think it's interesting to it because we can ride on like another JavaScript framework for doing X. So that's what we might be able to go forward. That hey, there's a new JavaScript framework which allows you to build rollups, which is like definitely an unseen thing. So yeah.
So we our private testnet, I'll say, is like right around the corner. And so yeah, we're actively looking to speak to folks who want to build, dApps in these languages on Ethereum in the very near future. So we are taking kind of like, you can go to our website, fluentlabs.xyz, and not to just to show a little bit, I guess. But yes, we're right there, so you can sign up.
Yeah, we're on DevNet, and I think one of the benefits that we have is we can ride on the backs of two giants. So we work closely with the Aptos Foundation and the Miston Labs Foundation, and really both of them see us as like a value add, because if you're giving more Move mindshare, get more people talking about Move, which is what I'm doing here today, it's better for the overall ecosystem. So they get to do their BD work, and we're like, you can deploy on Ethereum too. Isn't that cool? So that makes our lives pretty easy.
Yeah, we're still in the development phase, but we've also gotten to a very mature stage. So we're able to execute very complicated things like the AVM, the EVM, and we've also recently deployed Bonsai Pay on Sepolia. So we are actively looking for use cases that developers want to do, and we just want to see use cases that we possibly can make easier, can make them happen easier. But yeah, there's no network so far. So one network that we would love to get to at some point is a decentralized proving network, and we're still, that's still part of the roadmap.
One token.
No. No token.
Would you all consider yourselves like in the L2 space, or are you also sometimes thinking of going more to like the L3 space? Could you then deploy your system on another rollup?
Yeah, so for us, since we are doing like custom state machines, it doesn't really make sense to do an L3 because the value that you'll get like building on an L2, it's kind of like diminishing. Like you'll probably get like 1 or 2% more juice out of like running on an L2, running as an L3. So we would be focusing on like running in the L2 mode. However, like I mentioned, you can settle on any, like the way it is structured is that you can settle on any smart contract based chain. So definitely you can do an L3, but it's not like practically viable to do that. It's like you would get no returns.
So everything I've said so far has been focused on kind of our initial thrust, which is like the smart contract platform. But we're also, as Dimitri mentioned earlier in the lightning talk, we're building kind of a broader ZK framework that will support people building kind of like L3 like constructions. We like to call them like kind of shared apps versus like sovereign apps, because at the end of the day, they're just state machines, and you can change, you can put different things like data and proofs in different places. But like, yeah, if people kind of like align with the L2 in that kind of way, you can absolutely build L3s.
I think L3s confuse me as like, do we really need these things? Do we really not need these things? I think it's more about alignment with the particular ecosystem. We're just a VM, so you can use our VM for L3 if you so choose to. But I can't say that's a priority.
Okay.
Yeah, we're big on interoperability, so we'd be happy on any layer, to be honest. As long as you run the verifier, we're good to go. You can move your program anywhere you want.
I feel like I maybe should have also asked this earlier in the way you think about your project. And I think you kind of answered this here, where it's like, do you imagine your kind of iteration of an L2 or L3 or rollup just been once or like multiple times? Because I know in your case, it's many, many, many of them. In yours, you're going to create a framework, which I guess allows others to deploy it. But in yours, is it sort of like a focus, at least at the start, on a single rollup?
Yeah,
It's actually to you, sorry, yeah.
We're focused on some mainnet, have like a chain, build a DeFi ecosystem,
Yeah.
do all the right things to build out the right chain. I think the RAS space is rather competitive.
What is that?
The rollup as a service
Yeah,
space.
yeah, exactly. All the big
There's
ones.
a lot of rollup as service providers, but how many people actually want rollups is the question. I don't know, maybe you guys can weigh in on that.
I think it's early days. Like I'm definitely in the mindset that eventually there will be, thousands and thousands, if not more, rollups, and some micro rollups, some general purpose rollups, some kind of industry focused rollups. I mean, you can get to a point where you have, I don't know, like a little machine learning model running in the browser, and that can technically be a rollup or whatever. So like I think there's going to be a ton, but I think right now it's definitely from our vantage point, it's higher impact to the space to focus on kind of a general purpose platform. That's why we're kind of starting there.
Yeah, just to add to that. So I don't see rollup as like the end goal. I see rollup as a tool. So rollup is more like a process. Like you're building smart contracts. You don't call them like smart contracts. You call them apps. So eventually we'll get to a point wherein like we won't be saying like this is a rollup. We'll just call it like these are like some apps built using like maybe Movement or like Fluent or maybe Stackr or maybe RISC. So that's where we'll eventually go to, wherein like all of these things will be abstracted and these will be just apps. That's all.
Hard agree.
It's just, so it makes me think a little bit of the kind of Cosmos thesis a few years ago. They created the Cosmos SDK, and it was like anyone can make their own chain. And then there was this moment where everyone made their own chain. And then a lot of those chains kind of died. It turned out there's actually just a few who can make it. Do you think rollups could go through a similar thing with like a flurry of new rollups, but actually not all of them take hold?
Yeah, I think personally, I think it was more from the standpoint of like how the validators worked with the app chains. So the best part of building apps as a rollup is that you don't really need to bootstrap any of the security.
Yeah.
So that you get free, like you just get out of the box.
You get a
have
validator set.
You have such a vast validator set which like puts in so much economic incentive to not do anything wrong, and that's where rollup like takes over like a huge win over app chain. So that's my thought, but curious to hear others.
Similar thought. My mental model around it is like to get like escape velocity and really like bring an awesome execution environment into existence. You kind of have to do the consensus and social layer first. You have to get escape velocity around that first. And I feel like there's been a lot of attempts where that layer of things, both socially, the social layer basically, just like kind of never reached that escape velocity to where the execution environment can kind of proliferate. So like I definitely think that in kind of like he was saying, it just doing it in a roll-up world makes it so much easier for devs to just kind of like get started building these things. And I think that makes like all the difference.
I think the Cosmos ecosystem, like the technology pieces were still very important today. Like, sure, like all these app chain theses didn't really work out, but IBC is still an important standard. Tendermint is still an important standard, and they're used in the biggest chains today.
For sure. I didn't say Cosmos is dead. I said some of the chains are dead.
Yeah, for sure. So I think that's what's going to happen to like this rollup stack framework. Like rollups is going to be abstracted away. Like sequencers are just going to be normal parts. Like shared sequencers will be normal part of tech stacks. VMs are going to be normal parts of tech stacks. No one's going to be like, this is the rollup thesis or this is the modular thesis. It's just going to be like used in normal everyday technology.
Yeah, rollups are a really loaded term, actually, and that term has been growing in complexity throughout the past few years. To me, it's just transaction pipelining, very generically. It's a way for you to start off-chain with some piece of information or some process, and you want to land something in some chain that just confirms what happened in your process. Yeah.
I kind of wonder, if there's all of these rollups locked into the L1, do we end up with another kind of case where, like, yes, there's great computation on the L2, but like, could it clog the L1?
Yes.
Like, yeah?
Yeah, definitely.
Like,
At some point,
Yeah.
you would, unless optimizations are made at the L1 to scale kind of like the data throughput there, because then eventually it just ends up being kind of like a data dumping ground.
That's what I kind of just realized. I feel like the shared sequencer people know this, the MEV people know this, but it's just sort of dawning on me that, okay.
And that's the point of the DA layers, right? Like these alt DA layers are meant to make the gas fees next to nothing. Like that's the point of Celestia, that's the point of EigenD, that's the point of Availa, et cetera. Use Ethereum to settlement security, but in theory, over the next few years, the gas fees for these rollups should be next to nothing, which brings up questions like how valuable is a single, like one sequencer compared to shared sequencers?
Yeah.
Yeah, once you're on a distributed system, there are fundamental things you can't overcome, especially if you're doing a decentralized blockchain. You will, at some point, all you can do is just increase the requirements on the nodes that are participating in your network so that you're propagating blocks faster, you're verifying things faster. At some point, you just hit that wall. There's no way around it.
I think it was about time for us to open it up to questions. Just want to, should we do questions now? Is that okay? Okay, so I don't know if you want to take a minute to think of some questions. I have one last question to ask you guys, but yeah, if you want to just think about it, maybe put up your hand and they can bring you a mic, if you have any.
Are there any questions already?
I can continue
Yeah,
asking,
sure.
if you
Go
have
ahead.
some. So I was thinking actually as we were talking about like these frameworks, you know, there's the OP stack and basically every major L2 system is kind of following suit with their own. They are sometimes offering more versatility, like being able to run different bytecode in the rollup itself or choosing a different language or different VM. Are you competing with those in a way? Like, are you competing with, I mean, not OP stack maybe, but like the ZK, what did they call it? The ZK sync
stack?
one.
The
ZK
ZK
stack,
stack.
yeah.
I don't think we are competing. We're actually going to be using and partnering with these folks. So partnering with, like for example, OP Stack launched a Magic client, which allows for Rust-based VMs to launch on top of them. So they're actually partners with us. Maybe for Kautuk, it might be different.
That's interesting.
Yeah, I think, like I said, it's a different framework. It's not that we are going after their market. It's just that we are like in a different zone. So maybe they can come after us or something like that. But yeah, that's a possibility. But yeah, no further comments on that yet.
We just want to grow the pie, man. More devs.
I think what's really interesting is at the execution layer, it's very new. Like no one has really been pushing like bringing like everyone's been stuck to the EVM for years. No one's really thought of, hey, there could be other VMs to Ethereum. So I think the role framework space is pretty crowded. You have like everyone and their mom doing like role frameworks, but Kautuk's amazing, obviously. But I think the VM space is yet to be open up, where you can take different programming languages, take different VMs, and then partner with these larger role-up frameworks and be like, hey, we can move to Arbitrum or bring WASM to Arbitrum.
Did anyone have any questions? Did we have any hands? I can keep going. Should I just keep going? All right. I think we have a few more minutes. I actually wanted to ask, I wanted to kind of go back to the RISC-0 model and talk to you about this, like, or actually ask you about the sort of area your project or the RISC-0 and a few other projects are trying to kind of create. It's not the central chain with the rollups. These projects, I feel, kind of like float around them. They they touch them, but they don't necessarily have that same kind of hub and spoke look, at least. Can you speak a little bit more about what the vision is for that? Like, would you imagine RISC-0 working with these L2s?
Yeah,
or with these rollup teams?
Yeah.
Okay.
So we are.
And what would you do for them? Like, why would they work with RISC-0?
So one thing we're doing for Optimism, for example, is we're building basically a ZK version of their fraud proofs. So it's a single shot proof rather than an interactive process. And part of what we could do is basically just take over the ZK part, and you would just be free to actually build out how developers specify their apps or what the languages are. Or it could be something that is specified as part of one of the applications hosted on your frameworks. It really depends on what is best for the developer, because for some use case, like ML, for example, it could be that the best or most efficient way to do it is using the ZK ML stuff that we have, or from some other use case, it could be that something else is more efficient. A DSL, for example, could be just sufficient, could be not rigid, too rigid for the developer or so. So it's hard to say generically, It all depends on what the developer wants to do at the end. But of course, to optimize further, it gets more
Is it
complicated.
competing with Polygon's prover network? Or you work Polygon?
So we both have a ZK EVM, I would say. But we're basically the first type 1 ZK EVM because of how quickly we just put it together. Yeah.
With that OP deal, there's 2 projects, right? It wasn't just RISC Zero. It was
O1 Labs.
O1
as well.
Labs and RISC
Yes.
Zero. Okay. Are you guys building the same part together, or are you building 2 iterations of it?
So we both made different proposals for the RFP. And I'm not 100% in sync with what O1 Labs is doing, so I can't speak for them.
Got it.
Yeah.
This is sort of moving to maybe a different part of the stack, which is like the shared sequencer models. Does that affect you guys? Are you paying attention to that? And actually, you might be a good group to just ask, like, what is your opinion of shared sequencers? Will this be a thing? I'm trying to dig into this topic right now and having I've seen 2 sides.
Yeah. So sequencing, so we kind of divide sequencing into 3 categories instead of just like private and not, like shared. So it's like private sequencing, wherein the app is in control of the sequencing. The other is like third-party sequencing, which may not be shared. It would be just like specific for one application, but still like someone else does it. And then there is shared sequencing, wherein like several apps share a sequencer. So for us, like, we don't have like an opinion on like what the application should do. It's like left to the application to do that. Ideally, we would like to see applications doing their own sequencing. Like that's what we are thinking about. Like what happens if we let applications control their own mempool and just build the best possible transaction. We eventually see like that's an optimistic assumption that people would actually lean towards like doing good for their customers, like building the best possible MEV and then getting it back to the customers. But yeah, shared sequencing is something which, or third-party sequencing, something which could be valuable. Like, hey, some application, like I keep saying, like progressively decentralizing their own application. So let's say right now, when you ride when you book a ride for Uber or something, your transaction goes directly to the Uber server, and they decide on which drivers see your transaction and those kind of things. So what if in a situation like this is not traditional sequencing in Web3 standards, like some different kind of sequencing, wherein the user like sends a request, and then there is a sequencer which decides the algorithm on what drivers should see your application's request, and then they decide what matches your application. So
I never thought of the sequencer as that, but that's interesting.
yeah, so these are kind of like novel use cases that we are thinking in terms of like getting like Web 2 applications to decentralize their stack.
I think from a tech point of view, shared sequencing makes sense. But I have this running joke where I go to these shared sequencer groups and be like, how are you going to convince Arbitrum and Base to decentralize sequencer? And it's always like, regulation. I'm like, guys, that's like 4 to 5 years away in the best case scenario. How are you going to convince Base to use a shared sequencer? And I never get straight.
Also, decentralized sequencer is not the same as shared sequencer.
Yeah, there's too many issues here. In this world where DA gets cheaper, right now, Base can justify their sequencer because Ethereum costs like $7. They can charge $10. Their users won't care. In this world where DA becomes cheaper, now Ethereum transaction will be like $1, right? So now you can't charge like the 10%. The 10% extra is now 10 cents versus like a few bucks. So now like the sequencer models get like worse and worse, and there's no incentive for Base or Arbitrum to ever decentralize sequencer. In the cases I like it is when the Sila proposal, where Sila proposed to take all the validators for L1 and turn it into a layer 2. Now there's actually economic incentive for the sequencer to decentralize because Sila token holders have to stake the token to participate in sequencing the network. So it's actually value accrual back to the token, which makes it a sustainable business model. In the current situation, Arbitrum and Base and Optimism will never use a decentralized sequencer unless Gensler knocks on the door in the next 4 to 5 years.
Wow.
So
now we have questions.
We have questions.
Apparently, we're cutting a little into the break, so if anyone wants to take the break, maybe they're welcome to. Okay.
Hi, I'm Graciela. So I think my question is mostly for Rami. Obviously, we're all in Web3 because we care about decentralization and you guys have mentioned decentralization a few times, but I'm wondering, like, what is really in the way of, you also spoke to the maturity of your product. What's in the way for Bonsai Network to actually become decentralized and permissionless? And then I guess maybe to Kautuk, like, are you guys thinking about introducing decentralization to your proof marketplace?
Well, there is not much in the way except just having to work on it. Recently, we've open sourced many more components, for example, recursion improving, and we keep changing basically and reshaping how many parts of our system work. So I would just say it's not stable yet. It keeps changing, keeps adapting, and especially our focus for the next period is to get viable recursion out in a way that is also developer friendly. So that's not trivial. Also, the incentives for decentralized proving are not fairly easy to get right. So it's a matter of process. It's not, there's nothing in the way. It's just we have to work on it.
I think there's another question here.
Yeah, so I'm having a question. My name is Rishabh, and I just wanted to ask, like, how will the interoperability and composability of assets take place in these different rollups? Like, Anna mentioned that there will be shared sequencers, but if there are multiple shared sequencers, then there will be ecosystems of shared sequencers, like there are ecosystems of rollups. So if I want to send some assets from one ecosystem to another, there will not be, basically, how will the assets go there? And second one, will there be atomic transactions available in that case? What's your views?
I mean, also, I don't know if shared sequencers affect this so much, because I'm assuming there's going to be lots of bridges between all the rollups anyways, right? Like,
Well,
you're not
the
necessarily
biggest-
using the base layer as your...
If you look at the A16Z's Nakamoto challenge, the first problem noted in Web3 infrastructure is lack of atomic composability between rollups, specifically shared sequencing. And I think there's a lot, like, this is the next step in infrastructure that we kind of need to figure out, because sure, there's going to be if you believe there's going to be 1,000 millions of rollups, and they're all going to use their shared sequencers, great. Now you have like 10 different shared sequencers. The question is, how can you do one block atomic swaps? Otherwise, you're just going to fragment liquidity. I think what was really interesting, I was at NearCon, and one of the cool things they unveiled was like this pre-settlement layer they're doing with EigenLayer, where let's say you have shared sequencer on Arbitrum, shared sequencer on Polygon, and Optimism. You can submit all those transactions to this pre-settlement layer. Make sure if there's any composable swaps you want to do, and like atomic swaps. Once all the transactions finalized, then you send it to Ethereum. So I think this new thing that we're also looking into is if there's a possibility of pre-settlement layer for your a shared sequencer. So if you are trying to communicate with other ecosystems, I think Polygon CDK is implementing this, you can do atomic swaps. But so far, that's a problem in infrastructure that hasn't been solved.
Yeah, on
And I
that,
Oh, sorry. Hey.
yeah, I just had a follow-up on that one. So how do you think like it compares with like async composability as compared to atomic composability?
I know we're trying to be cut off right now, but atomic composability, I think, is important for liquidity aggregation. Let's say, for example, you have an off-chain order book. You need to be able to do one-block atomic swaps, or your user experience would be horrible because you get price feeds that's within multiple blocks, and then the user checks 4 blocks later, and now the price dropped 10 cents. So you need to have one-block atomic swaps for any order book to succeed.
I wouldn't just cut you off, man. I got one more question here, one more here, and after that, we're going to go into the lunch break.
All right, I'll be quick. So probably a question for Rami, but curious to hear your thoughts with all the plays about, snarkifying different runtimes. Like, you got ZK RISC-V instruction sets, ZK LLVM, ZK, WASM, and, all this kind of, levels of snarkification. Can you talk about what's the trade-off or general pros and cons, and why should project choose you guys as opposed to other players that's snarkifying different runtime?
Sure.
Yeah, I'll show my own project for a while. Why should you choose RISC-0? Well, one thing is maturity. That's what I just spoke about. You can actually deploy and run very complicated projects. The other thing is not everything is done in a VM style as we've done it. So we have some very particular features such as continuations, which allow you to run arbitrarily long programs inside the VM. So there is actual control flow in the RISC-0 ZK VM as opposed to being restricted by a certain circuit width or depth in other systems. And you don't have to do Rust per se. That's just what we support right now. If you can compile something else down to RISC-V, that is how you can also specify your guest binary or your ZK binary. So I'm definitely all for it. You know, it's a project I'm working on. But I would say, yeah, we have very strong tooling support compared to other projects. Does that convince you?
Right. So I have a question about actually compilers and security of this, right? Because with each of your VMs, there's a compiler needed. And how do you make sure that these compilers stay bug-free? Because one huge risk that comes with introducing the new system, whatever kind of the backend is, RISC-V, Move, or WASM, is that if compiler has a bug, it can impact everybody.
Yeah, so one nice thing is we actually don't have to do much work on the compiler level. We're using pre-existing pipelines to get out RISC-V code. So we don't worry too much about it. We let other developers worry that much about it.
From our side, security is in the VM itself. So sure, we're compiling slowly script to move bytecode, but the VM itself has built-in provers and formal verification. So let's say, for example, a slowly opcode can't be mapped properly with our transpiler. It'll throw a red flag within the SDK itself, and it won't be able to execute the transaction because it doesn't pass the formal verification methods. I think compiling to a non-move VM would be really difficult for us because we don't have the security guarantees that something like WASM would have. But because the VM itself has formal verification, we're able to handle any abnormalities that come up.
One other thing is just I remembered is something we were discussing is verifiable compilation. So you can actually run the Rust compiler inside of the ZK VM and have this verifiable output. Bytecode that is verifiably output by the program that you specified. So even if you have a malicious compiler on your machine, it wouldn't give you the same, or it wouldn't be able to prove its output. So a bit of a tangent to your question. Yeah.
I didn't have too much else. Just the more layers, the more things you're putting in between, like obviously it introduces like more risk. So I think that's definitely true.
Great. Okay, well, thank you all for this wonderful panel. Thank you all for joining us.